All right, the second part of 2.8 will be the compositions. So we're still working with two functions. We have our F function, 2x minus 3, and our G function is now negative x plus 3. I changed them up. And I want you to find the following. So our fifth example would be f of g of negative 4. This is not fog. This is a small little circle that represents of. So we're going to do the f of g of negative 4. Now, what this one specifies is that you do not plug negative 4 into both functions. This one does not work like the operations. So what you're going to specifically do is you're going to plug negative 4 only into the function that's closest to it. So it's going to look like we're working backwards. You're going to plug negative 4 only into g. That's your first step. Negative 4 goes into g because g is closest to the negative 4. So you're going to go to g's function, which is negative x plus 3. In the place, now watch your signs. That negative's on the outside. I'm putting my negative 4 in parentheses. Those two negatives will make a positive. So that's a positive 4 plus 3, which is 7. Now, to finish, you must take the 7 and now plug it into the f function. It's kind of like you're working backwards. So I'm going to take 7 and that goes to f function, which is 2x minus 3. In the place of x, I plug in 7. So 2 times 7 is 14, minus 3 is 11. And my answer would be 11. Whatever you get out that last function is your answer. So let's go over this again. You got f of g of negative 4. You're going to take negative 4 and plug it only into g. You do not plug it into f. You take your negative 4, plug it into g. We plug it in. 2 negatives make a positive 4, plus 3 is 7. Then you take 7 and you place it in the f function. So f's function is 2x minus 3. So I place 7 in. 2 times 7 is 14. Minus 3 is 11. Your final answer will be 11. Let's look at another example. F of g of 2. So you're going to plug 2 into the g function. So g function is negative x plus 3. So I have negative 2 plus 3, which is a positive 1. Then you're going to take that positive 1 and place it into the f function. Well, f's function again is 2x minus 3. So you're going to say 2 times 1, which will give you 2 minus 3 is a negative 1. So your answer is negative 1. Same operation here. We take 2 and plug it into g. We get 1. Then take 1 and plug it into f. And your final answer is negative 1. Another example. Let's do g of f of negative 5. So don't want you to think it's always going to be f of g. I can switch it up and do g of f. So same process. You're going to take negative 5 and plug it into the function that's closest to it. This time it would be the f function. So you're going to go to the f function, which is 2x minus 3. So you plug in negative 5, 2 times negative 5 is negative 10. Minus 3 is a negative 13. Then you're going to take negative 13 and plug it into the g function. G's function is negative x plus 3. So in the place of that x, you're going to plug in negative 13 and be mindful of your signs. There's a negative already there. So in parentheses, I put negative 13, which will eventually, 2 negatives make a positive 13. Plus 3 will give us 16. So my answer is 16. Same process. I took negative 5, plugged it into F, got negative 13, took it and plugged it into G, and my final answer comes out to be 16. Last one of the compositions. What if I gave you f of g of x? So now this one you're not plugging in an actual number because it's saying x. And anytime you have a plug-in of x, they want you to use the actual function. So your final answer will not be a whole number. It's going to be an expression, okay? It's going to be an expression. That means an x with a number, okay? So it says, and it's the same process, we're going to take the g function. That's the closest one to that x is g. Well, what does g function say? G function is negative x plus 3. Now, there's nothing for you to do, but you're going to take that entire function and you're going to plug it into the f function. Well, f's function is 2x minus 3. So where x is, you're going to plug that function. So I would put it in parentheses. Everything I plug in, I put in parentheses. So you got 2, there's x. So you're going to stick that function, negative x plus 3, in the place of x. Then bring down the minus 3. So this one looks like the notation problems we did before spring break. You're going to do distributive property with the 2. That would give me a negative 2x plus 6. Bring down my minus 3. And I can combine like terms of 6 minus 3. So I have negative 2x plus 3. And that would be my answer. That's my expression. So again, if I give you an x, you plug it into the g function. Well, that means take g's function, because x is already there. You're going to take the entire function and plug it into f's function. Where x is, you stick g's function, and you do distributive property and combine like terms. This will be the last example for compositions. Now, the very last part of 2.8 is doing a function definition, and I will show you that next. Y'all know I have a very big handwriting, so I'm trying my best with the little board. But it says, for each of the functions defined as follows, they want you to find A, B, and C. Now, this is not to freak you out, but A says f of x plus h. B says f of x plus h minus f of x. Then C has the exact same thing that was on B, f of x plus h minus f of x, but I'm dividing by h. So this is kind of like a definition, okay, for defining a coefficient. So what we're going to do, you can do it in steps, but we're going to actually do everything that's on C to get our final answer. They're just showing you in each step what I'm doing, okay? So I am going to try to write this little space down here. Let's do, I think this will be our example 9. Let's do f of x equals 6x plus 2. Okay? This is my problem. 6x plus 2. Now, what all this is saying, that in the place of x, you're first going to plug in x plus h. That's the very first step. So, in the place of x, you're going to plug in x plus h. Now, you're going to do distributive property. That will give you 6x plus 6h plus 2. So, technically, because you can't combine any of that stuff, this would be what you get when you do the A part. 6x plus 6h plus 2. Now, you have to continue with what B says. Well, B says take what you just did on A, which is the f of x plus h. Now, subtract f of x. Now, f of x is the original. What was the problem that I gave you? I want you to subtract it off. So, you're going to subtract 6x plus 2. But I'm going to put in parentheses because it's more than one term. So, this will represent B. This is what you did for A. 6x plus 6h plus 2. Now, you're going to subtract the original problem, which would be 6x plus 2. Now, here, you're going to do distributive property. So, that would give us 6x plus 6h plus 2. I just bring it down. But then I have a minus 6x and a minus 2. Now, at this point, things are supposed to cancel. On your B, you should have some things to cancel out. So, my 6x will cancel and my 2's will cancel. That's going to leave you with only 6h. Now, that's what you would get for the B answer, for the B part. It's not an answer, but the part. Now, C says take what you did for B, and the last step is to divide by h. Well, if you divide by h, the h's cancel, and you're left with 6. This is just a proof, you could say, to prove the coefficient that's on x. So you should always end with the number that should be the number in front of your x term. Okay? Now, we'll show this again through another example. And the good thing about videos that y'all can pause so you can have time to write all of this down. And try to write a little smaller. So that's my A, B, and C. Let me take it that way so I'll have a little bit more room to do the next example. So if we were to have f of x equals 2 minus x, I need to do A, B, and C, which is technically just C, for my final answer. So in the place of x, your very first step is to plug in x plus h. That's what you do. In the place of the x, you plug in the parenthesis x plus h. Now, you do know there's an understood -1 in front. So, you're going to do distributive property. So, that gives us 2 minus x minus h. So, that's what you would get when you do A part. Now, B says take what you just did for A, now subtract the original. So I'm going to subtract, and I'm going to put it in parentheses because it's more than one term. 2 minus x. And again, that's going to require me to do distributive property. So I bring down the 2 minus x minus h, and I'm going to distribute, and that gives me a negative 2 and a positive x. Now at this point, again, at B, things are supposed to cancel. Technically, your number and your x got to cancel out. So 2 and negative 2, that will cancel. Negative x and positive x, that will cancel. So you're left with negative h. So the last step says divide by h. Well, if you divide by h, the h's cancel. Now you do know there's an understood negative 1 on top. So that will be your answer, negative 1. And again, it's proven that that's the coefficient in front of x. Now we have looked at in 2.8 function operations and compositions and a definition function. This will complete all of the things in 2.8. So now you should be able to go onto my labs and do the problems for 2.8. You have an example of each one. Now you can, like I said, pause, rewind, go back on these videos, and actually have the time to write them all down. Next, I'll be showing you 2.2.